Okay, geometry fans, our topic for today is proving triangles similar. And before we start, let me tell you your joke of the day. Did you hear about the fire at the circus? It was intense. Get it? Intense? Okay, before we start with proving triangles similar, let's go back to congruent triangles. And we had a bunch of postulates that we could use for this. So let's do these 6 examples. Got 1, 2, 3, 4, 5, 6. Determine if the following triangles are congruent. If they are congruent, state the postulate that proves the congruence. Now for congruence, you need to know 3 things. In number 1, we have 1 set of congruent sides, 2 sets of congruent sides, and we have this common side in the middle. This side is congruent to itself. We call that the reflexive property. And what happens here, if I look at the top triangle, we have 1, 2, 3 sides congruent. So this is an example of side, side, side. They have to be congruent because of side, 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 that postulate. Now number 2, these 2 lines, the top and the bottom, that means they're parallel. With parallel lines, we have congruent angles. Look for the Z right there. And then we also have a backward Z here. And then we also have vertical angles, which are always congruent. The Z, those are called alternate interior. Alternate interior angles. They're always congruent when the lines are parallel. Unfortunately, what we have here, if I look at the top triangle, angle, 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 that does not prove triangles congruent. Now it actually proves triangles similar, so we're going to be using that today, but it's not enough for congruence. Angle, angle, angle means they both have the same shape, but they don't necessarily have the same size. So we need to know something about the sides. We don't know that any are congruent, so we have to say right now they're not congruent. Now number 3, we've got 1 set of sides, we've got 2 sets of sides, and then we also have congruent angles. Normally we would say, now this is a side, this is a side, this is an angle. SSA, now if you spell it backwards you have a bad word there, I'm not going to write that down. Side-side angle does not prove triangles congruent. However, there is a special case when you have a right angle, when it's a right triangle, and we call this side the hypotenuse, and this side is called a leg. When you have a right triangle, this is actually enough to prove triangles congruent. So we call that HL. That actually works. Hypotenuse leg works. Side-side angle does not, but if it is in a right triangle, we call it hypotenuse leg. That actually works. Alright, so we had number 1 was side, side, side. Number 3 was hypotenuse leg. Now number 4, we've got parallel lines. So we've got the Z. Alternate interior angles, those are congruent. We have 1 set of sides congruent. I could also say the vertical angles are congruent. Now in this case, I could also do the backward Z. For now though, I'm just going to look at what we have here. In this top triangle, here's an angle, and then here's a side. Now the side is not between the angles, so it's not ASA. The way that I write this is angle, angle, side. And that's good. If we had decided to do the other Z, the backward Z right here with the parallel lines, so these angles here would be congruent at these corners, then this would be, I could call this, here's my other angle, ASA. I could use that. So there's actually 2 answers to this one. Either one of those would be good, it just depends on how you're looking at it. Now number 5, 1 set of angles, 1 set of sides, and then we have the common side in the middle. Now if I look at one of the triangles, we've got a side, and an angle. Now the angle is not between the two sides. That's SSA, that's the bad word spelled backwards. No good, not congruent. Not enough information. Now number 6 is very similar. One set of sides. Here's the angle, one set of angles, and the common side. And this time, if I look at this, I have a side, and the angle is between them. This angle creates these two sides right here. That's what we call SAS. And that's good, that's enough information. Alright, so those are the things that prove congruence. Now our topic today is not congruence, our topic is similarity. We want to prove triangles similar. Well, there are 3 ways that we can do this. And I'm going to take you through these postulates here. The first one is called angle-angle similarity. Now let me read it, and then we'll draw a picture and I'll explain it, and I think that'll make more sense. If there exists a correspondence between the vertices of 2 triangles such that 2 angles of one triangle are congruent to the corresponding angles of the other, then the triangles are similar. Here's what it's saying. If, and let's draw a picture here, let's say we've got 2 triangles, and we'll call them ABC and DEF. If you know that 2 sets of angles are congruent, so if I know that angle A and angle D are congruent, angle C and angle F are congruent, then I can say for a fact that the triangles are similar. Then triangle ABC is similar to triangle DEF. That would be true. That's a true statement. Now that's called angle-angle. Now you might be thinking, well, when we did congruence you always need 3 things. You know, side, angle, side. ASA, AAS, side, side, side. We need 3 things. This is only 2. Now, it's called angle-angle, but it's really, you could call it AAA. We could say AAA. And here's the thing. If you know that 2 sets of angles are congruent, and in a triangle, all 3 of them always add up to 180, that means the third angles have to also be congruent. Okay, so we could say that all of them are the same, but if you know 2 of them, then you actually know the third one. So that's why we just call it angle-angle. You don't need the third angle because you just know it's going to be congruent already. Okay, so angle-angle proves similarity, not congruence, similarity. All right, flip it on the back. Okay, now we'll talk about the next one. Now, there is a side-side-side similarity. There's side-side-side congruence. We also have side-side-side similarity. And here's what this one says. Okay, if, again we'll draw 2 triangles here, and we'll call them ABC and DEF. Now this time, side-side-side means we know information about the sides. Now the sides are not congruent, but let's go ahead and label 2, 4, and 5 for triangle ABC, and we'll say 6, 12, and 15 for DEF. Now what happens here is that when figures are similar, the corresponding sides have to be proportional. Well, if I take the smallest side of triangle ABC, which was 2, and I take the smallest side of triangle DEF, which was 6, that reduces to 1/3. Now if I look at the 2 middle sides, which would be 4 and 12, and I look at the 2 biggest sides, which would be 5 and 15, notice that all 3 of these fractions are equal. They're all reducing to 1/3. What this tells you, all right, they all give you 1/3. This means that the sides are proportional. Sides proportional. And if the sides are proportional, then the figures have to be similar. So if sides proportional, therefore, triangle ABC is similar to triangle DEF. And it is important that A and D correspond, B and E correspond, C and F correspond. I have to put them in the correct order so that each point corresponds to the other point. All right, so that's side, side, side. Now the last one is side, angle, side. Oh, hold on, we got an announcement. Okay, so now we'll do side, angle, side. If, let's draw our pictures again. So we have ABC, we have DEF. Now this time side, angle, side would look something like this. Let's say AC is 2, DF is 4, CB is 3, FE is 6. And let's say that angle C is congruent to angle F. Now, if you look at the sides, 2 over 4 and then 3 over 6, those are proportional, right? They both give you 1/2. And then the side or the angles between them are congruent. So if you have two sets of sides that are proportional and the angle between them, the included angles, are congruent, then that's side, angle, side. Side, angle, side. The angle has to be between the two sides. So if we have this, then we can say, then triangle ABC is similar to triangle DEF. So we've got angle, angle, side, angle, side, 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 side. Those are the three postulates that will prove triangles similar. That's the end of part 1. So let's move on to part 2 and we'll look at the examples.